Hello there, ROS developers, and welcome to a new open class number 163. And today we are going to be talking a little bit about multi-robot navigation. So how to configure it, how to configure a regular navigation package. In this case, we are going to be working with localization. So how to adapt a localization package for one single robot in order to use it for navigating multiple robots simultaneously. Yeah, so welcome everybody, and let's get already started. So as always, let me switch here to my computer screen. There we go. I am already in the construct application. So let me know here in the chat if everything is fine, sound is fine, image is fine. If there is any issue, let me know here in the chat so that I can know about it. And yeah, so as always, the first thing that we need to do before we start with the class is to get the rosject, the class rosject. So as always, very easy, very simple. All you have to do in order to get it is to click on this button that you have here right above the chat, which says fork, and open the class rosject. So I'm going to click here myself, and by clicking here, this is going to generate a copy of this rosject into your account. So you are going to have this rosject forever in your account. You are going to be able to revisit it tomorrow, next week, next month, in case that you want to work on it. You are going to have it there in your account forever. And as you can see also, it's going to automatically bring you here to the rosject main page, which is the one that I have right here, with the streaming area here at the right side, with the live video feed and the chat, so that you can write here and make any questions, write feedback, whatever you want. And yeah, so this is going to take a few seconds to fully load. So yeah. Meanwhile, let's let me just talk about today's class. So we are going to be seeing how to configure the localization for two robots, in this case for two Turtlebot robots. But there are many things that I'm not going to be explaining in this class, all right? So for instance, we are going to be working with a localization package which is already configured, yeah? And there are some navigation basic concepts that I'm not going to be explaining, okay? So I'm going to give all that knowledge for granted. Then in case that you don't understand some parts, you are missing some of the knowledge that I'm not going to be explaining today, just let you know that we have our ROS2 navigation course in the academy. This one here, ROS2 navigation, where you can get all the knowledge about how to configure from zero a navigation stack for your robot, okay? How to build the map, how to configure localization, path planning, obstacle avoidance, all these things that I'm not going to be explaining today. All this is in this course, okay? Today we are going to be doing a small part of this unit, which is multi-robot navigation, okay? So just to let you know that we have this course in the academy in case that you want to learn more. All right. Then let me come back here to the rosject. This should be almost loaded already. There we go. So once it finishes loading, you are going to see also that the notebook automatically opens. Yeah, this is a Jupyter notebook where I have placed all the instructions for today's class. You are going to find here some explanations, also some commands that you are going to have to execute today, also some pieces of code, etc. Everything is contained here inside the notebook, so you can come here and check it out by yourself. Then, yeah, so the first thing that we are going to do in order to start with the class is to launch the simulation. First thing that we need is to have a gazebo simulation running. So, very simple. For this, all we have to do is to execute these two commands that are here in the notebook, in the how to launch the simulation section. So, in order to run these commands, of course, we need a terminal. Then in order to open a terminal, you have to click on this first icon in the bottom bar here. You can click here and this is going to open a brand new shell terminal, as you can see. And then this is a regular Linux shell where you can type commands. So what I'm going to do in this case is to copy directly the command here from the notebook. So I'm going to select it and Control C to copy it and then paste it directly here into the shell to make it easier and faster. And then also with the second command here, which is to run this sh script, that it's going to start the simulation. Then another thing that I'm going to do, meanwhile the simulation is being loaded here, is to open the code editor. The code editor is the second button that you have here in the bottom bar. Then let's click here as well in the code editor, because this is going to allow you to visualize with a graphical interface all the workspaces, folders, packages, files from the rosject. Okay. For instance, if we go inside the ROS2 workspace and inside the src folder, you are going to find here the sh script that we have just executed. Yeah, if you double click, you are going to open it, and then you can see the contents of this script. Yeah, so basically we are doing some sources, and then we are executing here a ROS2 launch command to start the simulation. All right. Then, yeah, so after some seconds, the simulation should be loaded. And the gazebo window should be automatically opened. All right. Yeah, so here it has loaded one robot. Now it's loading the second one. And there we go. Gazebo window opens here. And we should be able to visualize here the gazebo simulation with GZ client. There we go. Yeah, so let me orientate it properly. There we go. Yep, and here we have the simulation. Yeah, with this environment here and the two robots inside. We have here two Turtlebot 3 robots. Yeah, one here and the other one here. All these blue things that you see here are the lasers of the robot. All right. Okay, so we have the simulation. Then let me know here in the chat, by the way, because I'm not seeing any message. So have you been able to load the simulation properly? Yes, no? Do you have the simulation running like I do? Yep, says Seth. All right. I have been able to load the simulation and have it running, says Jeff. Great. Yes, yes. Perfect. Okay. Then before we start, well, no, actually we have already started, but before we get into configuring the localization system for the two robots, there is one thing that is important when working with multiple robots, which is to have them properly configured. Why do I mean with this? So, for instance, if we run here a ROS2 node list, okay, here we have, so by the way, leave the simulation here running, okay, and then you can open more shells by clicking here in the add button, okay. For instance, we can rename this one to sim, so that we know that this first shell contains the simulation, okay. Then, and this one, let's name it like this. All right. So if you run here in another shell a ROS2 node list command in order to list all the nodes that are currently running, you're going to see that we have the same nodes, this Turtlebot 3 laser scan, Turtlebot 3 joint state, Turtlebot 3 IMU, Turtlebot 3 diff drive, and Turtlebot 3 1 robot state publisher. Okay. So we have the same nodes 2 times duplicated with different namespaces, all right? Then this is very important. When you are working with multiple robots, you have to have them organized and separated into namespaces, all right? So that the nodes and the topics of both robots don't collide. Yeah, because at the end, the nodes are going to be the same, the topics are going to be the same with different values, but the same. So you need to have one way to differentiate which node is from one robot or another one. And this is done through namespaces, okay? Which is this. Then I know that all these nodes are from the Turtlebot 3 robot 0, and all these ones are from the Turtlebot 3 robot underscore 1. Yeah? The same goes for the topics. Yeah? So if we run here a ROS2 topic list, we are going to see exactly the same. So we have a command bell topic for robot 0 and another command bell topic for robot 1. Yeah? Then one scan topic for one robot and another one for the other robot. Yeah? And this is managed through these namespaces. Okay? So it's very important that you have your robots properly configured like this. Yeah? All right. Then, yeah, so this is what I am explaining here. Then, yeah, the topics, great. And for instance, we can command the robots, yeah, with by running a teleop twist keyboard node. I'm going to do it right now. Yeah, let me copy and paste the command here. Yeah. So here I am running an instance of the teleop twist keyboard node like this, and then I am remapping the command bell topic to this topic, TB30, the namespace, and the command bell. Okay? Then if I run this node, I'm going to be able to teleoperate one of the robots, right? So let me put this here. Yeah, and then, as you can see, I am teleoperating this robot here. The one, yeah, let me zoom a little bit so you can see it better, yeah? See? There we go. And if I change the topic namespace, let me stop it. Whoop. I have collided with one of the robots. Yeah, let me stop it here. All right. Yeah. And then if I run the same command, but changing here the namespace to TB31, I'm going to be able to teleoperate the other one, the other robot, right? There we go. Yeah. Great. All right. Then let's do one more check before actually going for the localization part. Which is to check the current state of the frames. Yeah. Which is also important. So for this, you can run this command right here. These two commands, in fact, they are two commands. So copy them from the notebook, paste them into the terminal, and execute. So here we are using the view frames node from TF2 tools, which is going to generate the transformation tree of the robots, of the simulation. Yeah, you're going to have all these output, and then here from the path where you execute this command, which in this case it's ROS2 workspace SRC, here it's generated this PDF file. Yeah, then let me come here to the code editor where you're going to find it also, and then here you can very easily just right click on the file and download. Save. Okay, and then I'm going to open it right here, and this way you can check the TF trees of the robot. So as you could expect, the TF trees are exactly the same, but we have two TF trees. One is for the TB30 robot, and the other one is for the TB31 robot. Yeah? But the structure is basically the same. All right? Then, okay, so one of the things that's going to happen, yeah, here I'm going to skip this part because we are going to move directly to configuring the localization by using a map that I already have. But so the map that they are going to be using for navigation, this is a question I'm going to make to you. So the map that they are going to use for navigation, should they have each one their own map, or can both of the robots use the same map for navigation? What do you think? They can use the same map, say Seth, they are in the same space. Give them the same map. Okay, same map. All right, yeah, so you are right, okay? They are going to use the same map. So basically what is going to happen here, once I launch my map server, is that I'm going to have a map frame, right? And this map frame is going to connect both robots, yeah? So both robots, in this case, the odometry frame, is going to be sorry. So each odometry frame from each robot is going to be connected to the same map frame, right? Okay, so we are going to check this later once we launch map server and everything. Then now that we have made the introductions, we have checked how our robots are properly configured, each one with its own namespace, with its own topics, etc. Let's go for the localization system. Let's configure the localization system, okay? Then here, if you go to the code editor and you open you are going to see that you have this TB3 multi-robot ROS2, okay? Here you have all the packages for the simulation. And then we have also a map server package here already created and a localization server, okay? The map server is the one which is going to be in charge of providing the map to the robots, and the localization server is going to be in charge of localizing these robots into the map, okay? Then here we have already our map server with its launch file. Everything is already done, okay? I'm not going to explain how this is done because it's not part of this open class, but if you want to learn about all this, you can check it out and learn it here in the ROS2 navigation course in our academy, okay? Then same for the localization server, we have this already done, but this is done for one single robot, okay? So here we have a localization launch file where we are launching a map server node and an AMCL node, yeah? So what do we need to perform localization? We need a map, which is provided by the map server right here, and an AMCL node, which is the one in charge of localizing the robot in the map, yeah? And then we have also a lifecycle manager, which is in charge of managing these nodes, yeah, of starting up the nodes, stopping them, and so on. All this is handled by the lifecycle manager, okay? But this launch file is prepared for one single robot, yeah? So in this case, we have two robots, as you have already seen. So how can we modify this launch file and, of course, configuration files in order to handle localization of two robots? Okay, so this is what we are going to be doing now in the following minutes, step by step, okay? It's not complicated, but there are lots of little things where you can do mistakes, okay? So let's do it all together, step by step. Then, step one is to add a namespace to the launches of AMCL nodes, okay? Then we have said already that our localization system can use one single map, right? So both robots can use the same map. Okay, then this means that we actually can launch one single node of the map server, right? So we can launch one single map server node, which is going to provide this unique map, which is going to be used by the two robots, right? But what about the AMCL node? Can we use the same AMCL node for both robots or not? No, says Amna. No, you cannot. Exactly. So each robot is going to need one instance of the AMCL node, right? Then, okay, so in order to differentiate each AMCL node, we are going to use a namespace, okay? So this is what step 1 refers, yeah? Then, how can this be done? Very easily. So we add a namespace here, right? We can add a namespace here at the beginning of the node, and then this is going to be the AMCL node for the TB3.0 robot, and then we are going to create another one with the namespace TB3_1, right? Then let's already create our new line file, which we are going to name like this, multi_localization.launch.py. So here inside the launch file, I'm going to right click, new file, and create this multi_localization.launch.py. There we go. Okay. Then let's come back here and copy the contents of this launch file. Copy it here, right? Then let's start here by adding a namespace. Oops. Namespace equals TB3_0 and the comma, right? And then we are going to add another node down here, which is going to be with the namespace TB3_1, right? So this is the first step. We have one map server and two AMCL nodes, each one with a different namespace. Yeah? Okay, let's continue. Okay, then since we are using two AMCL nodes, we are going to have to use as well a different parameter file for each node, right? Then here we have the AMCL config, here we have the map. The map, we can leave it as it is, but for the AMCL configuration files, we are going to create two of them, yeah? So we can name them nav2 yalm, I don't know, TB3 or 0, for instance, and this one we are going to name it _1, okay? Then this one, we are going to load it in for robot 0, and here we are going to load it for robot 1, right? Okay. Then next step is to create these configuration files. Yeah. Now these configuration files, we are going to name them like this: TB3_0_AMCL_config.yaml. So let's create two configuration files here inside the config folder. New file TB3_0 and new file TB3_1. Okay. Very well. And now we can copy the contents of this AMCL here. Or actually, in order to make it simpler, we are going to select, copy and paste already the the example for one of them, and we are going to review it now, okay? So this is the example for the 0 robot. So let me copy here the contents and paste it here. Yeah? So what do we have here? First of all, first difference, we can see that in the regular one, we specify here as the root the AMCL node, right? In this case, our AMCL node has a namespace, right? So we have to indicate this namespace here as well, okay? We have to indicate the namespace /AMCL, okay? So these parameters are going to be loaded for this node, TB30 AMCL, okay? Then what else? We need to indicate also this namespace for the footprints, okay? So each robot, if you remember, I already closed it here, let me open it again actually, or download, yeah, okay, yeah. So the frames, these are the frames of each robot, right? Then if we check here the base footprint, we are going to see that the frame is named TB30 base footprint, yeah? So for one robot, our footprint was named as base footprint. Now we have to include the namespace, right? So our base frame ID is going to be renamed to this, TB30 / base footprint, right? The same thing goes for the odometry frame. Yeah, this is the odometry frame name, so we have to add the namespace, TB30 odom, right? What about the map frame? The map frame, it doesn't matter, right? Because we are using one single map. So for the map, it's not necessary to add the namespace. Yeah? Make sense? Then what else? We have here one last thing that worth mentioning, which is the topics. Yeah. So for configuring the AMCL node, we need to provide information about the laser topic, right? Because the AMCL is going to compute the estimated position of the robot based on the data that it receives from the laser of the robot, right? So we need to indicate what is the topic where the AMCL node can get this laser data from, right? Then here, as you can see, we are putting simply scan, yeah? So an important, an interesting question that you might be doing yourself right now is, hey, Alberto, but the topic is not named like this, right? So if we come here and we do a ROS2 topic list, there is no scan topic, yeah? They have a namespace as well, the topic names. So why are we not adding the namespace here? Well, in this case, we are not adding it because it's automatically done, yeah? Since we are indicating a namespace here for the node, this namespace is going to be automatically added as a prefix for this topic, yeah? So this is going to be the namespace of the topic, and this is going to be the name of the topic, okay? So for this case, for the case of the topic, we don't need to add it because it's automatically done by the system. Yeah, because we have this namespace here. All right? And what about the map topic then? For the map topic, it's going to be also added, right? Well, no. In this case, it's not going to be added because we are indicating a / here at the beginning. Yeah? So if we specify the topic with a / here at the beginning, it's not going to append the namespace. Okay? So if we specify the topic with a / here at the beginning, it's not going to add the namespace. If we don't specify this forward slash, it's going to add the namespace. Okay? Yeah, it's a little bit tricky, but yeah. Once you know these little things, it's pretty simple. So ROS, is there a transcript and supporting GitHub white code of the lecture? No, we don't have this in GitHub. No, you have it here in the rosject, ROS. I didn't put it into a GitHub repo. Yeah, exactly. So Jeff is saying yeah. So this is a relative path, right? And this is a absolute path. Okay? So at the end, this is going to be converted to this, right? And this is going to be converted to this. Yeah? This is the difference. Okay? Let me take this out. Okay. Here we have some commented part at the end, which is to indicate the initial pose by default from the configuration file. But we are going to leave it commented because we are going to do this. We are going to set this initial pose from RViz in this case. Okay. Then yeah. So once we have one configuration file, we need to create the other one, right? So let's copy the contents from this one and paste them to the other configuration file for the other robot. And now all we have to do is to look for the TB3 zero coincidences and modify them by TB3 1, right? So let's go one by one in this case. So TB3 0, we're going to change it to TB3 1. Also here and also here. Yeah? And yeah, also here. TB3 1, TB3 1. So we have changed all the namespaces to TB3 1. But is that okay? Or do we want the map topic to also have a namespace prefixed? No. Jeff, so as we said at the beginning, we are going to use the same node, the same map for both robots, right? And because we are using the same map for both robots, then the topic is going to be the same. It's going to be map. Yeah, both robots are going to get the information of the map from this topic. Okay, so we are only launching one map server node, so we only have one map. Exactly. Yes. Yeah, exactly. Map is the topic the robot will listen to in order to get the map. Exactly. All right, then, okay. Now let's come back here and actually put the correct names for the YAML files, yeah? So the actual names are TB3 _ 0 _ AMCL _ config, right? TB3 _ 0 _ AMCL _ config. Yeah, so this is one and the other one is the same, but TB3 1. Okay, so we have the two configuration files which are loaded into each AMCL node, right? Okay, now let's continue. Then step 3, add the nodes to the lifecycle manager. Okay, so here sorry. So we're going to have to do an update here to the lifecycle manager in order to take into account the new nodes, right? So here, let's come here and update. So the map server is going to be the same, right? We are still launching one single node for the map server, but now we need to specify here the two AMCL nodes, right? So this is going to be tb30/AMCL, and let me copy this, and then we need to add here, right after the other AMCL node. Yeah. So now we are launching three nodes: the map server, the AMCL node for robot 0, and AMCL node for robot 1, right? And besides this, here there is this bond timeout parameter that needs to be added. I don't remember now exactly why this is added, but I remember that if you don't add it, some issues happened. Okay, so I'm going to add it just in case, this bond timeout right here. There we go. Okay, and finally there is here one last modification that we need to do for the map server. Yeah, so here we are going to specify topic name and the frame ID of the map server. Okay, so let's go back here to the map server. So, yeah, so probably this is not necessary, yes, but this way we are going to make sure that there are no errors that come from this. Yeah, so we are going to specify the name of the topic, which is going to provide the map, and the name of the frame. Yeah, we want to keep them to map. Okay, so let's add this here as well. There we go. Okay, so my fault. I have not yet taken the ROS2 navigation class from the construct. Okay, don't worry, Jeff. All right, so I think that we have it, right? Then down here, in case that you missed some step or whatever, you have here the solution. Okay, you have here the full multi-localization launch file. Yeah. Then let's just review it to see if more or less we have something similar. So we have two configuration files, right? Each one for one of the robots. Great. We have one single map that we are loading, right? Then we are launching here one map server node. Then we have here the two nodes for the AMCL. Yeah. One is using the TB30 namespace, and the other one is using the TB31 namespace. And each one of them is using a different configuration file. Yeah? And then finally, we have the lifecycle manager, where we are starting the three nodes: map server, AMCL 0, and AMCL 1. Right? Okay. Now, let's compile all this. So let's come back here. Let's go to the root of the workspace here, to home user ROS2 workspace, and compile with a call build. There we go. So that all the new launch file that we have created and the new configuration files get installed into the system. There we go. And source. Okay. And now we should be able to already launch it. Okay. Let's see if I get any error. I did something wrong. Yeah. So ROS2 launch, localization, server, and multi localization.launch.py. There we go. Okay. So here, yeah, everything looks correct. And yeah, so here we are getting the messages from AMCL from the two nodes. Yeah, TB30 AMCL and TB31 AMCL. So both nodes are complaining that, hey, In order to work properly, I need to get an initial position for my robot. Yeah. Then how are we going to do this? We are going to do it through RViz in this case. Okay. Then let's launch RViz2 here, and we are going to configure RViz2 also for multi-robot navigation. Okay, which it also has some interesting tricks that we are going to be doing here. Yeah. Then step 5, launch multi-robot localization, and step 6, configure RViz for multi-robot. This is what we are going to be doing now. Okay. All right. Then let's come here and start adding things to RViz. So the first thing that we are going to add is a laser scan visualization. Okay. Then let's click on add and select the laser scan display. Okay. And now you can duplicate it, add another one, whatever you want. Okay. Well, in this case, let me configure the first one. So how are we going to configure the laser to be able to visualize both lasers? Yeah, the laser readings for each robot. Then we are going to point each one to its topic. Yeah, one topic is TB30 scan and the other one is TB31 scan. Yeah, and also we are going to modify the color of the display. So let's come here to topic and select TB30 scan. Okay. Then yeah, and for changing the color, actually, yeah, here we go. Oh, I can't. Yeah, I need to visualize it in order to have this activated. So for now, we are going to leave it here. Okay. By the way, also, let's change the reliability policy to best effort. Yeah, because for lasers, usually that is the one used. Yeah. So just to make sure, then let's set the topic and change the reliability policy to best effort. Okay. And then nothing is showing. Right? Yes, so right now nothing is showing because actually I need my AMCL node to generate. So let me ask it to you. Why I am not able to visualize the laser scan? Let me see some comments from here. I guess I was asking for a document to download that you are showing the steps. Yeah, so this you have it in the rosject. Okay, ROS? In the rosject of the class, you have this notebook. I'm behind because my Qualcomm build seems to be taking a long time. I missed the ROS2 launch command. I'm betting it's ROS2 launch localization server multi-localization launch pi. Yes, exactly. Yes, this is the command, Jeff. I have it here. ROS2 launch localization server multi-localization.launch.py. Okay. Then does somebody know why I cannot visualize the laser? Well, actually it's because I am using the map frame. Yeah. For navigation, usually in RViz you are going to use as fixed frame the map because you are interested in visualizing everything, all the information with respect to the map, right? So typically you are going to set map frame as fixed frame. Then I am not able to visualize the laser because right now at this point the map frame is not connected to the robots because my localization system is not really working yet. Yeah? Yeah, exactly. Seth is saying need a transformation to map frame. And this transformation from map to the ODOM frame of the robots is done by the AMCL node. But the AMCL node, in order to work properly, needs an initial pose, right? So until I don't provide this initial pose, my localization, my AMCL node is not going to generate this transformation. So actually I cannot visualize anything here. Yeah. So let me then let's start by adding a map display here, because we actually need it. So where do I have it? Map. Let me add the map here and configure it for the map topic. And then here I need to change it to transient local, okay? The durability policy to transient local, there we go, okay? So here we have the map and the laser scan. Okay, then let me save config as, let me save it in here in the ROS2 workspace, for instance, in SRC. Localization, save, okay? I am doing this because sometimes during the process RViz crashes, okay? So keep saving as much as you can the RViz configuration so that RViz doesn't suddenly crash and you lose everything, all right? Okay, now, so we need to set the initial pose, the initial estimated pose of one of the robots, right? Then, how do I do this from RViz? I do it using the 2D pose estimate tool, right? But if I use this 2D pose estimate, what initial pose am I going to set? For what robot? Right? So how does RViz know which is the robot I want to set the initial pose? Okay, so this is done by using a panel which is tool properties. Yeah. Then in order to get access to this panel, you have to come here to the panels section in RViz and check here the tool properties. Okay. Check it, and then this is going to provide this tool properties window here, right? Now, here, you can configure, let me try to make this a bit bigger, if I can. Let me see. Yeah, like this, a bit bigger. Yeah, I'm not getting the pixel here. Okay, anyways, you can see here, we have the 2D pose estimate and the 2D goal pose. Yeah. Then here, if we open, for instance, the 2D pose estimate, we can configure the topic. Yeah. So the topic for setting the initial pose is going to contain as well the namespace of the robot, right? So you can modify here the topic name, and for instance, at the beginning, add TB3 underscore TB3 underscore 0 / initial pose, right? Then now I have configured my 2D pose estimate to publish into this topic, TB3 underscore 0 initial pose. So I am going to be setting the initial pose of the robot 0, the robot with the namespace TB3 underscore 0, right? Then now let me save this again, save configuration. And now if I click here into the pose estimate and for instance set an initial pose, yeah, I can start visualizing the laser readings. Yeah, let me make them a little bit bigger so that we can see them better. Let me increase here the size. Yeah, there we go. Okay, and save here. All right, let me see here because I am seeing. URL, where is location to see the steps? Document text. There is no URL. So here we are working on a rosject, okay? Then, in order to get this rosject, here from the live class page, in our, the live class initial page, here, you can click on this button here, fork and open the class rosject. And this is going to create a copy to your account of this rosject, all the project that I am working on. Okay? With the notebook and everything is there. I'm getting no map received. ROS, it's not the notebook that... I see that Jeff answered you. Okay, so I figured I changed the durability policy in the wrong drop down. Okay. Yeah, QoS, very important. Yeah, to properly configure the quality of service, the QoS of the topics. Yeah, this reliability, durability, etc. Because depending on your settings, you're going to be able to visualize or not. Okay. Then let me add one more thing, which is the TF. Yeah, I want to add the TF for the robot. Then for this, for the TF, let me see how it was. What do we have here? Yeah, for TF. Oh no, actually, yeah, there we go. So here we have the TFs of one robot. Okay. And now I'm going to do the same for the other robot, right? So let me duplicate here the laser scan. And what I'm going to do is to change the namespace of the topic, yeah? From TB30 to TB31, right? There we go. TB3_1 scan, okay? And now, in order to localize the other robot, what do I need to do now to localize the other robot? What do I need to change to set the initial pose of the second robot? Somebody tell me? The topic, says Seth. Change pose estimate. Yeah, so I need to change the topic from the pose estimate, right? From here, from tool properties. So instead of setting the initial pose for the TB30 robot, I want now to set it for the other robot, which is using the namespace TB31. So I change the topic here for the initial pose. Yeah, and then I can come here and set the pose estimate for the other robot. Let's put it around here, for instance. There we go, okay? And now, in order to differentiate both robots, I'm going to change here the color, okay? By changing here the color transformer to a flat color, yeah? And now I have it white. You can change it to any other color that you want, I don't know, yellow, something like this, okay? And now I have, oops, let me take this out from here, yeah. Yeah, so here we have now our map with the two robots, right? And each one with its own laser, okay? Now there are more things that we can configure here. Let me see what we are doing here in the notebook. The laser scan we already did, the robot model. Yeah, we can load the robot model as well, if you want, to see how it's done. Yeah, so let's do it very quickly. So let's add here a robot model display to be able to see the robots as well. Yeah, then how to configure this properly? So in the robot model, we need to change the description topic, first of all. Yeah. So in this case, it's going to be robot description with the respective namespace. Yeah. So let's add it here, tb3_0 robot description. And we need to as well indicate here the TF prefix, yeah, to tb3_0. And there we go. There we have, now we can visualize the model of one of the robots, yeah? And now we can, of course, duplicate this again and change it for the other robot, for tb3_1. tb3_1 and tb3_1. And now we can visualize as well the other robot. Yeah, let me save this. Save configuration. Okay, almost done. Yeah, we have already done this, the tool properties, we have seen how to change this, to the pose estimate. Yeah, and there is one last thing that we can do as well, which is to add here the particle cloud display. Yeah, here at the beginning, inside the nav2 RViz plugins, you have this particle cloud, which is interesting in order to visualize the particles of the AMCL filter, to see how good actually the localization is. Yeah, and this we can set it also here with the tb3_0 particle. Actually, let me check because I don't remember exactly the topic. So let me check here. What is the topic name? ROS2 topic list grep particle. Okay, yeah, here it's particle_cloud. Okay, so tb3_0 particle_cloud. There we go. And for the QoS, I want to check the QoS as well. So ROS2 topic info tb3_0 particle cloud and -b verbose to get the information of the quality of service. Okay. Then the information from the particle cloud publisher, which is here, is best effort and volatile. Yeah, so I'm going to change here the reliability to best effort. There we go, to make sure that it's correct, best effort. There we go. Okay, so now I'm going to add another one for the other robot, for robot 1, here, tb3_1. Okay, and then let me change the robot, the color as well here to blue, let's say. There we go. Okay, so now, for instance, if I set the initial pose of robot 1 again, I can visualize the particle cloud of this robot, right? And we can do the same for the other one. Yeah, it's already here. Yeah? So we can visualize the particle clouds for each robot. Yeah, save configuration. There we go. Let me see the messages here. I got stalled at load the RViz configuration because it didn't specify where the file is. Load the RViz configuration. Ah, yeah. So there is this. So there is this configuration here, localization RViz, which is already done to you. Okay, I did it all from zero in this case. So I have configured everything from zero in a different one. Okay, because I think it's more interesting to do it everything step by step than to load one which is already prepared. Yeah, but if you want to load one which is already prepared and configured, you can, yes, you can use this one, the one that you have here, localization.rviz. Okay. Yeah, and then one last thing that we can do here is to check now the frame tree. So if we come now again here and generate a TF tree using the view frames node, I'm going to do this right now. Then let's come here. Here we have the new PDF generated. I'm going to download it. And if I open it, what can we see? Well, what we were expecting, right? We discussed this at the beginning. So initially we have the two frames, the two frame trees separated. Yeah. So now that we have the localization system working, we have the two frames. Yeah. The one for the robot 0, which is this one, and for robot 1, which is here. Both of them are connected through the map frame. Yes? And yeah, so here we have a perfectly working localization system for two robots. Yeah? Have you been able to get it working? Yes? No? Any issues? So we are going to leave it here, but a very similar process would be applied for the path planning, okay? So for path planning, we would do something very similar, yeah? So just summarizing what we did is we are using a single map for both robots, then we are launching two nodes for AMCL, one for each robot, yeah? And in the lifecycle manager, we need to add both nodes for AMCL, yeah? And then you have to be very careful by properly configuring the namespaces, yeah, for each robot. For the frames, you need to make sure that the frames are correct for each robot. Also, the topic names are correct for each robot, yeah? Then, in order to do the same for path planning, it would be something very similar, okay? But that I'm going to leave it for, as homework for you, so that you can try it on your own, okay? I'm behind due to my issues. I will work through the notebook since it will be my rosject, my account. Exactly. Yeah, so Jeff is a little bit behind, but if you are a little bit behind, don't worry, okay? Because this rosject, you are going to have it in your account forever. So you can review it at your own pace. So don't worry, you don't need to hurry. Also, now as I finish the open class, we are going to upload this class to YouTube, okay? So that you can review it also in YouTube as many times as you want, okay? Then, yeah, so I'm going to leave it here. Thanks a lot to all of you for attending to this class. I hope that you liked it, that you enjoyed it, and especially I hope that you have learned something. That's the purpose of these classes. And yeah, so thanks a lot. And I will see you again next Tuesday with another open class. So yeah, until then, as always, take care and keep pushing your ROS learning. Bye bye.